So here, the utility maximization problem, we assume the existence of a utility function that represents underlying preferences, and we also assume that this utility function is continuous, that it is twice differentiable, and that it's quasi-concave. The quasi-concavity follows from the requirement that the upper contour set be convex. As it turns out, the requirement will be strict convexity of the upper contour set, so strict quasi-concavity of the utility function to ensure that there's a unique solution to the utility maximization problem. The utility maximization problem is to maximize the utility of consumption such that the consumer spends no more than what they have, which is a W, which is an endowment, a starting endowment, which can be thought of as wealth or income. So the consumer chooses a consumption bundle in the budget set in order to maximize his or her utility level. So we solve for this. I'll spare you the Kuhn-Tucker necessary conditions, the Lagrangian techniques. I think you're all familiar with this. We identify the optimal consumption bundle and we call it X star, which is a function of P and W. Here, by the way, we have an additional requirement I should write up here, which is that X cannot be negative, right? That would not make sense. You could not consume negative amounts. Now, when X is single valued, when there's a unique solution to the maximization problem, we're going to refer to this as the Walrasian demand function. This is also known in other textbooks as the Marshallian demand function, but somehow Maskell, Winston, and Green, which we've been using here, uses the terminology of Walrasian demand function. If the solution is not single valued, then we would have a correspondence. The utility function here is, if you follow the terminology I used in deriving the envelope theorem, the utility function is the objective function, which we're trying to maximize. If we take the solution and we plug it into the objective function, we get what's called a value function, and here the value function is the utility of X star, which itself is a function of P and W. That's the maximum utility achievable at given prices and income or wealth. And we can refer to this as the indirect utility function, terminology V, a function of prices and W. So the indirect utility function here is the value function. It's defined over P and W, and it gives you the maximum utility achievable at given prices and given wealth endowment.